Hello everyone, welcome to the 60x coding stream. Today we'll be doing a model evaluation stream, and the model we're gonna evaluate is Grok Code Fast 1. So let's give it a few more minutes. If you're here early, come and say hi in the chat. Okay, so let's start the stream. So a bit of introduction on the model. Today we'll be testing Grok Code Fast 1. It's a very long name. I think this one is kind of just the ID, and then there's a good name for the model from OpenRouter. And this is actually the same model that was released a few days ago as Sonnet. So this one was a stealth model that was released to Rucode and some other coding tools, and it's very fast, right? That's why it's called Sonnet. And now we have confirmed that this is from XAI and it's called Grok Code Fast 1. Not sure if it's exactly the same model, but it's definitely from XAI and definitely a Grok model. So today we'll be testing it out in our coding evaluation tasks. So for our coding evaluation process, we will run it on 7 coding tasks that I have curated. For each of these tasks, the model will generate an output, and then me as a human will assign a rating for the task. For this model, we'll use the default temperature that is provided by XAI, and we'll connect directly to the XAI API to issue the request. So you can see here I have my API keys and console ready to go, so we can see the request coming in. Yep. Why is it weekly? That's so weird. Okay. And yeah, so let's go ahead and start running the evaluation. As usual, we have these 7 tasks. So let me go ahead and start on the evaluation. Let me update the stream plan here. As we go through each one of them, I will explain what they do. So to save us some time, I'll start the task. I'll let the model run, and then I'll explain what each task is, right? So we get a little bit more time to we don't wait for the model to generate response, although Sonnet is quite fast. You know what, because Sonnet is so fast, we don't actually need to do that. So we just run the explain and then run the model. So for the first task, is called Tailwind CSS v3 z-index. So this is the task to test the model on a Tailwind CSS bug. So if I look at the prompt here, so I have the full prompt for this task here. So it's basically asking the model to identify a bug in the code and then fix it. So the bug with this code is that, as you can see, if I open up this page inside a browser, and I click this setting, you can see that the setting button kind of blocks the setting model, right? So this is because inside the code there are some invalid Tailwind classes like z60, which is supposed to set the z index, but it's actually not a valid CSS Tailwind CSS class in v3. So this task is specifically for Tailwind version 3, and this is not an issue in version 4, right? So we're testing the model's capability to understand this versioning and then fix this bug. So the model need to understand that for Tailwind CSS version 3, this is not valid, and then that's the bug in the code. Alright, so let's fire up our Grok Code Fast 1 on this task. So I have the prompt and context, and then let's just run it. It should be very fast based on my testing on the Sonnet. I always call it Sonnet. Sonnet and Sonic is so similar, so I need to call this model Sonic. Oh, it's actually surprisingly slow this time. I wonder why it's so slow. It's not supposed to be this slow. Okay, let's take a look at the tokens. Okay, so it's actually quite fast, but it generated a lot of tokens, right? A lot of characters. Oh yeah, I think it's also a thinking model, right? That's why it's so long. Let me enable reasoning. Yeah. So this is also a thinking model, that's why it's taking so long. It generated 3,000 thinking tokens before generating a response. Okay, so I'm gonna disable the cost here, and then for this task, I think each model is given 2 tries, right? So this is gonna be our first try. Let me copy this code into my model response and then test this out. This is gonna be Grok Code Fast 1. This is the first attempt, so let's copy the code. Okay, I have a script that automatically detects if the response is correct or not, so I'm just gonna run that script to test. Let me check the script. Okay, verbose. I need to standardize all the scripts. Okay, so alright, so I think it did not actually find the problem, so let me come back to the response and see. Yeah, it didn't identify the problem, and then the code also didn't fix the problem as well. So this is gonna be a 1 out of 10, and the bug is not identified by the model. So the first attempt is 1 out of 10. Let's try again. I'm surprised it thought for so long. It spent a very long time in thinking, but still the answer is wrong. I don't think we can see the raw thinking token, but it seems to be the process. Okay, the second one also doesn't look very promising, but let's try it out. Copy the code, run the script. Yeah, I also didn't fix it. Just for completeness sake, let me just open up this HTML and see if it's indeed problematic. Yeah, it's still not fixed, right? So if you open up a correct fix, like from GPT-5, then you can see that the model is not blocked by the button, right? So that's the correct fix. So clearly, Grok Code Fast 1 did not fix this in both attempts. So it will get a 1 out of 10 for this task. Alright, that's the first task. We're done, and then let's move on to the second task, right? So for the second task, we have clean Markdown, which is a medium level task. And for this task, basically we're asking the model to kind of clean up a Markdown file and then convert it into a plain text file, right? So basically we have a Markdown file with some from matter, some formatting, some components. These are actually MDX, and then we wanted to convert to a just plain text file, right? By following these rules. So these are the rules: unwrap code block, unwrap Markdown links, replace headings, remove all these extra things. So this is testing the model's ability to write TypeScript code to kind of do cleaning. So this is an example output. And let's see how well Grok Code Fast 1 does on this task. Okay, I'm just gonna select this model and then go to each task. Okay? This is the clean Markdown. Let me run the code, run the script. So this is the prompt and these are the context. I'm gonna run it. It should be relatively fast, but it's a thinking model, so we don't know. We can actually compare the thinking tokens because I've implemented the reasoning token counting capability into my app, CTX eval, so we can actually see the amount of reasoning tokens being consumed by each model. I think this should be quite fast. Let me go back and commit this one, and then go to the project for clean Markdown. Yeah, I need a verbose script for this one, so let me just add a verbose script for this one. I think I don't have it yet for some reason. So we have S verbose and then yeah. So now if I run test verbose, it should run the okay. Let's see. So Grok Code Fast finished. It's quite a short response. It's very short. So let's see how well it does. We have this code here. Gonna paste it here. Run the test. Wait, why did it not run it? Oh, this is weird. Wait, why did it not run the test? My script somehow didn't detect this file for some strange reasons. Let me check what's wrong. Oh, okay, looks like this file was not saved correctly. Okay, so let me try again. Okay, let's save the file and then run this again. Okay, so now we got the output, which is 100% match. That's a good sign. So yeah, so Grok Code Fast did very well for this task. It's 100% match, and in terms of output length, it's less than 1000 characters, which is actually on par with the top models for this task. So in this case, it will get a 9.25 for the correct answer and the short code. Okay, so that's for this task. And then now we have completed 2 out of 7. So this is the current rating for these two tasks. Let me just filter this by coding. We are on to a very good start. Now the third task is clean Markdown, which is a more difficult task than the clean. Sorry, the third task is clean MDX, which is the harder version of clean Markdown. So basically, the clean MDX just have more things to clean up. Like, so this is a sample import. We have the import statements, multi-line import statements, and more complex MDX components to remove. So this is much harder than the previous clean Markdown task, and a lot of models can struggle on this task. I think so far only the Grok 4 got a 100% match, and all the other models didn't get a 100% match in my testing. So let's see how well this model does, right? And let me just remove the temperature since I don't need to look at it. Let's run this MDX with Grok Code Fast. Yep. So we can take a look at some previous response. So for example, Cloud Opus 4 has some leftover import statements after we run the script. So we have some results from the past models. As you can see, DeepSeek v3.1 did very poorly. Grok 4 I think was the best model for this task in previous tests. So it generated a very clean text file. Let's see how well Grok Code Fast does. Maybe it's as good as Grok 4. But I don't really like the thinking process. I wish I could turn it off. Let me check if this model can be turned off. Reasoning. Yeah, I don't think the reasoning can be turned off. Yeah, I'll have to investigate if I can turn off the reasoning. So let's see the output. So this is the code that is written. Looks quite short. And for this task, each model is given 2 tries. So I'll run this test twice. Model response, Grok Code Fast, 1.yes. Copy the code here. Clean MDX. Okay, this one doesn't have test verbose. Okay, so we have 5 differences here. Let me check the script. I think I should have a verbose script here as well. Yeah, I have the verbose script. I just didn't add it to the package.json, so let me just add it. Yeah, so now I have the verbose script. Looking at the output, so looks like it didn't get rid of the import statements. And then there's some new lines here, and then there's some leftover MDX component, which is this one. Okay, so it's not too bad, but it's also not the best model. So let's see, right? So text was all there, so it's 9, and then there's leftover component. I think there are like 4 new line issues, and then there's leftover imports and components, right? So that is a 9 minus 0.5 minus 0.5, which is 8, and 8 minus 0.5 is 7.5. So this one will get a 7 out of 7.5 rating, which it puts it on par with Sonnet 4 GPT 4.1. But each model gets 2 tries, so let's try again for this task. Just to make sure we're actually hitting the right API, let's check the API console. Today is 28. Okay, maybe I need to more granular. Why is it not showing up? Okay, maybe there's some delay on the graph showing up. Yeah, I'm not sure why. I think this graph is not real time for some reason. Oh, why is this 1020 to 1020? That doesn't make any sense. Okay, now it has some stuff. Yeah, so it's definitely hitting the correct endpoint. I don't know why this defaults to like today the same time from 1020 to 1020. That doesn't make any sense. I think this is a very bad default. Let's see. So we have the response here. Looks like a little bit longer than the previous one. So let's try it out. I'm gonna copy this to my model response. Copy the code here and run my script. Okay, so I think this is slightly better than the previous one. Only 4 differences. And we can see that the MDX component seems to have been removed, so there are only like new line problems and imports. Let me check the output. So we can see some import not being cleared, some new line issues here and here. I think overall it should score higher than the previous attempt. Let's see, right? So it started with a 9 out of 10. No text was removed. We have some import statements, so minus 0.5 for leftover import. And then we have a few new line issues. I think this is 3 new line issues. So we have 3 new line issues and leftover imports. Okay, so that would be 9 minus 0.5 minus 0.5, which is 8. Okay. So we have an 8 out of 10. I think overall that will put it higher than Sonnet, GPT-4, and Opus. Yeah, that's pretty good for this task. So it's basically tied with some of the top models for this task. But Group 4 is still the best. Yeah, so that's for this task. So far so good. I think it's pretty good. Oh, let me remove the DeepSeek V3. We don't need that. Let's see. Let's move to the next task. So the 4th task we have is the benchmark visualization task. Let me just run the model because it's actually a thinking model that takes quite long. So I'm just gonna run the model and then explain what this task is about, so that we can save some time. I'm gonna run the model and then I'm gonna explain what this is. So this is a benchmark visualization task, which tests the model's ability to generate visualizations. So basically I give it the model the data of 2 benchmarks, the Ader Polyglot and then the K-Core's LM Arena, and then ask it to generate a visualization of the benchmark results of these 2 different benchmarks, right? So ideally the model will generate a side-by-side comparison for each model, and then we can see the trend of whether a model performing well in one benchmark also perform well in another, right? So that's the idea. So I have some previous benchmark generations here, and then each of them is rated from 0 to 10. You can see some of them look pretty good, and then as we go down the score, they look uglier and uglier, and some of them don't render properly. So that's the idea of this task, is to generate a HTML visualization. It looks like Grok Code Fast has finished. Let's see. For this task, each model is given 1 try, unless it didn't render properly, right? Then we give it a second try. So let me go to the model visualization task and then add the output. Okay, so we have the HTML file here. Let's open it up and see how well it does. Oh, okay, interesting. Oh, that's interesting. So the model just generated two bar charts, which are side by side. I guess it's not a bad design. I don't think I have seen any other model do this. Let me see. Most of them are not like two completely different bar charts. Yeah, most of them are like one bar chart but two parts, right? So this one is like two completely different bar charts. Let me look at the code if it's actually two charts. Yeah, it is actually two charts. Okay, that's interesting. I don't think I'm gonna deduct points just because they render two charts. I don't think it's that different from rendering two charts like side by side. So I would think still this is a pretty good chart to have. Let me just get the response here and then, oops. So this is what we got from Grok Code Fast. This is the raw image, and then I'm gonna annotate it with the model name. Which is Grok Code Fast 1. So this is what Grok Code Fast 1 generated. Okay, so let's take a look at how do we read this response. We don't have any labels. This doesn't have any label. So that will be a baseline visualization without label, 8 out of 10. It's not side by side, as in like the two bars are side by side for each model. It's not. We don't have labels. Visually pleasing. Okay, I guess so. Pretty good. I think it's pretty good, pretty clean. I'll give that. So it will be 8 plus 0.25. So that's no labels and visually pleasing. 8.25. Yes. Okay. So that's 8.25, which is not bad. This is the first model that scored 8.25 for this task. Interesting. Let me also update my repo with this new model. So I'm gonna add it to my README. 8.25 would sit here. Okay. So we have Grok Code Fast 1. Human rating 8.25. So this is quite interesting, right? So Grok Code Fast generated two completely separate bar charts, which are visually pleasing. I think the autocomplete was pretty good, right? Yeah. Okay, so we'll just use the autocomplete and give it an 8.25 out of 10. So that's the group here. All right. So that's the benchmark visualization task. If you look at the overall score, it's looking pretty good, I think, so far. 1, 8, 9.25, 8.25. Not the best, but also not the worst. Let's move on to the next task, which is the number 5, folder watcher fix. So again, I'm gonna fire up the task first, and then we'll explain what this does. save some time, because this is a thinking model that takes some time to think. Alright, so the folder watch fix is basically a normal Vue.js task that is kind of like trying to add a new feature add a small new feature into a Vue.js code base. So we have this TypeScript file and Vue.js file, and then we're supposed to add a new feature, which is to handle the ignore suffix when blah blah blah. So this is basically a real life task that I have in my own project, and then I just encapsulated all the context and the prompt into a task. So this one only has one file, but the file is quite long, right? So this file is 800 lines. So this task will test the model's ability to understand long code files, and then add a small new feature to it, which I think all the top models are able to handle pretty well. It's just whether the output is verbose or not, because I have the instruction here to do not output full code, right? Only show the relevant code. Use command to represent parts that are not modified. So if the model gives us the full code, then its instruction following capability will be considered worse. I'll give it a lower score. Wow, so it's only generated 700 characters. That's a very short answer. Interesting. That's almost the shortest answer I've ever seen. Let's see. Yeah, that's the second shortest answer, just slightly longer than Sonnet 4. Wow. So it's actually really concise, and I think it did solve the problem, and then it also solved the additional problem that I have. So if I look at the rubrics, oh, that's really surprising. It did really well for this task. So it solved the task. It added an extra helpful logic. So that's basically calling two functions, both of these functions, ignore suffix and ignore folder. So some models only get one. So if you get two, then it's extra 0.25. And then it's actually very concise, so add 0.25. So that's 9 plus 0.25 plus 0.25, that will be 9.5. Okay, that's a really good score to have. I think it might be the highest score. Let me check. Yeah, it is the highest score, right? Yeah, it is higher score, tied with Opus 4 and Horizon Alpha. Okay, very good performance on the folder watcher fix, 9.5 here. Okay, I didn't expect that. That's some surprising performance. Now let's move on to the TypeScript narrowing task. This is gonna be a challenging one. So basically, it's a very uncommon task of handling type narrowing inside TypeScript. So basically, what this task is that I have a code that doesn't compile, right? So there's some TypeScript error, and then we need to use some TypeScript narrowing to avoid this TypeScript error and then make it compile. So there are several approaches to this, but then most of the models get this wrong because this is a very challenging task, and then it's very uncommon. A lot of models don't know how to solve this. So if you look at the results for this task, so far I think Sonnet model seems to be very good at this, but all the other models didn't do very well. So a lot of models got 1. Even GPT-5 got 1, right? Some models can solve this, GPT OSS did pretty well on this task. So let's see how well Grok does. Grok Code Fast one, right? So for this task, each model is given, I think 2 tries. Yeah, each model is given 2 tries for this task. And then the prompt is written in such a way that the model can provide 2 different answers, right? So if multiple methods work, we'll give plus 0.5. But if the model provides multiple methods, but one of them is wrong, we will minus 0.5. So to be fair. So this is the evaluation rubrics for this task. Okay, so we already have the first response. Okay, so I guess it used the in keyword, which is highlighted here in my result. Let's see how well this does. Does this actually compile? I think it will compile. Probably it will compile. Let me try. So the script to run is just test. Yes, so it compiled successfully. Okay, so it solved the task using the in keyword, which I specifically noted inside the criteria that this is actually a suboptimal solution, but it works. So I'll give it 6 out of 10. Only one method provided, so nothing else. I guess it will just be 6 out of 10 for the first attempt. Okay, so that's 6 out of 10 for the first one. Let's give it a second try. So far so good. I think so far the model is doing pretty well. I think it's very close to the top models. I think much better than the open source ones that I've tested recently, especially the DeepSeek v3.1, which I tested yesterday. It's very bad. Probably don't want to use that model. But this one is pretty good, at least on my evaluation tasks. Let's see the second output. This is interesting. So looks like it does use the what do you call this? The this method is called a predicate, right? I think, yeah, it does use predicate. So I think this looks about right. I think this would compile successfully, but let's try. Okay, so far I'm very impressed. It seems like the second method would actually compile. Yeah, so the second method also compiles successfully using the predicate method. So if you don't know about it, TypeScript predicate, which is a quite advanced technique, right? A lot of models don't know about this. Yeah, so type predicate. If you want to know more about it, you can read more on how this works. But basically, Grok Code Fast knows about this and use the correct technique to solve this. And they only provided one method which is working, so it's 8 out of 10, which is very impressive to say the least. This is very impressive. So it got the correct answer. Yeah, so it's actually almost close to the top. It's only like lower than Opus 4. So if I go back to my benchmark and then add back the, where is Anthropic? Opus 4, Sonnet 4. You can see that, where is it? TypeScript narrowing. So yeah, so it got a silver medal because it's ranked 2nd for this task, which is a lot better than all these open source models. Yeah, okay, so far looking pretty good. I think this model was I tested it last week for like in Cline, I think. Yeah, and it did pretty well on. So I tested the Sonnet model with Cline, and then it did pretty well as well. So this is the this is the YouTube. Sorry, this is the live stream that I did with Cline. So for this, the Sonnet model already did pretty well for this. So it's kind of expected that it did pretty well in my coding eval as well. So this is a real world task testing. If you're interested in more in Sonnet, you can Sonic, you can check out this video. Okay, so let's move on to the last task, which is a very simple Next.js to-do app, and then we add a very basic feature of adding the creator time for the task. So the prompt is like this: add the creator add field to do, update both backend and frontend. So this is a very simple task that most models can solve. And then the challenge of this task is to follow the instructions, right? So basically the prompt also says that do not output full code, only output the part that needs to be changed. So if the model ignores this instruction and output the full code, then we'll deduct points for the response. And then for this task specifically, I have different prompt variations. Basically, different models respond to different prompts, and then like some of them require stronger prompts, some don't. Some you need to be more explicit, like Gemini. So we have different prompt variations here. Let's try the normal prompt first to see how well it does. I think so far it's looking like it's gonna be one of the top models. Very good performance. Let's take a look at this. So these are normal stuff, everything looks correct. Yeah, but I think, yeah, unfortunately I think it outputted the full code instead of just the part that need to be changed. So if you look at the output length, this is 1700 characters, which is very similar to these models that outputted the full code, right? So this will go into the category of outputting the full code, getting an 8 out of 10. But that's not the only prompt I have. I have a I have a alternative version of the prompt that tell the model to be more concise. So let's try the concise prompt if this works. This works for Gemini models, but I don't think it works for other models. So let's try it out. Okay, so it did work to a certain extent, right? So it's now using commands to replace the file or to represent the code that didn't change. And then in terms of characters, it did drop to 1100 characters. So that will probably be a wait, that's actually very concise, right? Yeah, I think it's supposed to be rated very concise, but actually not, right? So this part can still be more concise. So I will give it a 9.5 or 9.25. Oh, but I have the exact rubrics here. Actually, I should look at this. So less than 1.2k. This is less than 1,200 characters. So I should give it a 9.25. Yeah, let's just follow the rubrics. Even though this part can be more concise, but I guess the import is already very concise. So let's just give it a 9.5 based on the rubrics. That will make it the top rated model for this task as well when we give it a concise prompt, right? So that's very good. Alright, so that's all the tasks. So let's look at the result. Okay, so it's definitely, let me highlight this group. It's like in the middle, right? So it's better than all the open source models except for GPT-OSS, but it's definitely worse than Sonnet and Opus in terms of performance. If we ignore the open source models, let me remove the bad open source models and then add back the Gemini, GPT 4.1, GPT 5. Okay, so it's actually quite close to GPT 5, which is not highly ranked, by the way, in my testing. So it's close to GPT 5 and Gemini 2.5 Pro. The only reason why it's not better is because it did very poorly on the Tailwind CSS task. Otherwise, if you look at the other performances, this model is actually very good, right? So it's kind of similar to GPT-5, Gemini 2.5 Pro, worse than GPT 4.1, GPT-OSS 120B, and then the Sonnet 4 models are still the best. Yeah, so there you have it. That's the evaluation for Grok Code Fast 1. Yeah, overall a very solid model. I don't really like the thinking part. It makes the model much slower, but in terms of performance, it's pretty good. I think because it's cheaper than GPT-5. I think so, right? I think this is cheaper than GPT-5. 0.2, 1.5. Yeah, definitely cheaper than GPT-5. It's definitely a better model to use than GPT-5. Yeah, 1.25 and 10. And then this is 0.2 and 1.5. Yeah, definitely recommend using this model over GPT-5. Yeah, so I think the price is the main attractive thing for this model. If you don't need the best model, then this is a very good model for like a normal coding task. Can easily solve all of them. Yeah, so that's all for today's stream. Thank you everyone for watching, and I'll be testing all the new models and also doing my AI coding stream on Saturdays. So given that Grok Code Fast is a very good model, I'll probably be continue using it in different tools and trying it out on more real-world tasks because it's cheaper than Sonnet. The performance is kind of okay, better than Quantry Coder. Yeah, I think that's one thing that a lot of people will care about. So if we compare it to Quantry Coder, it's actually better. So I think that's, in terms of the cost, you probably want to switch from Quantry Coder to Grok Code Fast. Even if the Grok Code Fast has good tool call support, I think so far it doesn't look like it, but if the support improves, then it's gonna be very good in all the coding tools. Yeah. So that's the overall conclusion for this model. Thank you everyone for watching. I will see you in the next stream.